Hi everyone, welcome back. Today we're going into section 4.2, which has to do with radicals and roots. And not radicals, not like the campus radicals we see in school, although I don't think there's too many of them these days. No, these are mathematical radicals, or really just roots, types of roots of numbers. So let me just remind you what these nth roots are. So if n is a positive integer, again, like 1, 2, 3, 4, so on, and c is a real number, then the nth root of c is denoted this way, and by this symbol. And what it's defined by is the number that if you raise it to the nth power, you get c. So this, in a way, this is kind of like the opposite of exponents. So we're basically saying, for example, if we know that 2 squared is 4. So 2 is the number that we raise 2 to get, that is the number that we square to get 4. That's what it is. So similarly, the square root of 64 would be is 8, because 8 squared is 64. Okay, and I should say that in the case when n is 2, we usually don't put the 2 up here. We just write the usual square root symbol. Now, a couple things. If n is odd, then the nth root of c always exists and is unique. Okay. If c is negative, then this nth root is going to be negative, and if c is positive, this is positive. If n is even, it gets a little tricky. If n is even and c is positive, the nth root of c always exists and is positive. Now, there are two numbers in this case that would work. That if you raise it to the nth power, you get c. You could also take minus the nth root of c, when it's the opposite of whatever this number is. And then when you square it, or when you raise it to the nth power, if n is even, that minus sign goes away. Okay. So there are actually two solutions that would work, but when we write the nth root of c, we're talking about the positive value. Okay. So and if we're talking about the negative value, we put a minus sign in front of it. If n is even and c is negative, then the nth root of c does not exist, and I should say that, or it does not exist as a real number. It exists in the complex numbers, but in this course we're going to be staying away from complex numbers, at least for now. Okay, so you can't take the square root of a negative number, you can't take the 4th root or the 6th root or anything if n is even. All right. So, as we said before, square root of 4 is 2, the square root of 64 is 8, square root of negative 9 does not exist because this is a square root and we have a negative number here. We can take square roots of fractions. Square root of 16, or 1/16, is the square root of 1/4 because 1/4 squared is 1/4 times 1/4, and that's 1/16. Cube root of 8 is 2 because 2 to the 3rd is equal to 8. The cube root of negative 1 is negative 1 because negative 1 cubed is equal to negative 1. The 4th root of 16, that is 2 because 2 to the 4th is 16. The square root of 9 over 25 is 3/5, because again you can check that 3/5 times 3/5 is 9/25. Right? It turns out that the 5th root of negative 243 is negative 3, because if you're on your calculator you can check that negative 3 to the 5th is indeed negative 243. The 4th root of negative 5 does not exist because 4 is even and negative 5 is negative. And then the cube root of 5 does exist, but it's not an integer or a fraction. Okay? This is where we need our calculator, and it turns out that this is approximately 1.7099. And I'll show you how to do this on your calculator in a minute. Okay. So again, you can take the cube root, or you can take the nth root of any real number if n is odd, and any positive number if n is even. Okay, it doesn't have to. It doesn't. The result might not be a nice round number though. Okay, so where do exponents come into this? Well, this is where we can talk about fractional exponents. So instead of writing the radical sign all the time, sometimes we use fractional exponents, and we define c to the 1 over n to be the nth root of c. And the reason for that kind of makes sense, right? Because we want c, if we take c to the 1 over n and we raise it to the nth power, right? We remember how exponents, if exponents are going to follow their exponent rules, this is c to the 1 over n times n. But this is just c to the first, which is c. Okay. So that's why we can get away with fractions, and we can talk about negative fractions. C to the minus 1 over n is just, again, whenever you see a negative exponent, you can rewrite this as just 1 over the expression with a positive exponent, right? So this would be 1 over c to the 1 over n, which is the same thing as 1 over the nth root of c. And then if we have a general fraction, m over n, this is just the nth root of c to the m, or the nth root of c raised to the m. These are both the same number. Okay. So let's just do a few examples here. So the 16 to the 1/4 is the same thing as the 4th root of 16, which we know is 2. The 64 to the 1/3 is the cube root of 64, which turns out to be 4. You can check that 4 times 4 times 4 is 64. 4 to the negative 1/2, it can be written as 1 over 4 to the 1/2. And we know that 4 to the 1/2 is the square root of 4, which is 2. Okay, so the answer is 1/2. There. 9 to the 3/2 can be written as 9 to the 1/2 raised to the 3rd power. So this is the same thing as the square root of 9 raised to the 3rd power, but the square root of 9 we know is 3. And 3 to the 3rd is 3 times 3 times 3, that's 27. Negative 8 to the 5/3, this is negative 8, the cube root of negative, let's write this as negative 8, the cube root of negative 8 raised to the 5th power. Okay, we can see that that's a little easier if we do this. If we take the root first, because we can see that we already know what the cube root of negative 8 is. That's going to be negative 2. And then negative 2 to the 5th is going to be negative 32. Then 81 to the 3/4, this would be the 4th root of 81 raised to the 3rd power. Okay, so this would be the 4th root of 81 is actually 3, right? 3 times 3, 81 is 9 times 9, and 9 is going to be 3 times 3. So 3 times 3 times 3 times 3 is 81, so this will be 3. And again, 3 cubed is 27. Speaking of 27, what's 27 to the negative 2/3? We can first rewrite this as 27. 1 over 27 to the 2/3. And then we can rewrite this as the cube root of 27 squared. And the cube root of 27 is 3. And 3 squared is 9. So we get 1/9 as our answer. Negative 8 to the 3/2. This is going to be the square root. Now, this is actually, when we try to do it this way, this is the negative 8, square root of negative 8 to the 3rd. And as soon as we see this, we can stop, right? Because we can, it can't take the square root of a negative number. So this does not exist. Okay. And even if we rewrote this the other way and try to take the square root of negative 8 to the 3rd, negative 8 to the 3rd is still negative, so can't take the square root of a negative number. 32 to the 1/5, this is the fifth root of 2, or rather the fifth root of 32, which is 2. That's 2 to the 5th is 32. And negative 1 to the 1/7. This is, well, this is going to be, you think about this, so this will be the 7th root of negative 1. And when you think about it, 7 is odd, negative 1 to the 7th is negative 1, so this is just negative 1. Okay? Alright. And then, just before we go on to the next one, remember I said, if we want to find out how to find the square root, the roots in our calculator, in some calculators they do have a cube root key, but you can always compute this as just entering 5 to the 1/3 in your calculator. Okay, that's what this is, and that's how. So if you want to find the 4th root of 5, it would be 5 to the 1/4. Okay, you can always do that on your calculator. Okay, and then just some other stuff here. Going back to exponential functions, defined if f of x is defined this way, this would be we just replace x with whatever's in here. So f of 0 would be 5 times 32 to the 0, so that would just be 1. Okay, so this would just be 5. F of 1/5, this would be 5 times 32 to the 1/5, and we all know that 32 to the 1/5 is 2, so this is 5 times 2, so this would be 10. 5 to f of 2/5 would be 5 times 32 to the 2/5, and 32 to the 2/5, this would be the 5th root of 2 squared, and so this is 2. Then this is I'm sorry, this should be 32 here, and this is going to be 2 squared, which is 4. So this is 5 times 4, so this is 20, and so on. And you can check that this next one will be 40. I'll leave you to check that. F of negative 1/5, this is going to be 5 times 32 to the negative 1/5, and this is going to be just positive 1/2, right? Because 32 to the 1/5 is 2, so 32 to the negative 1/5 would be 1/2. And you can check, so this would be 5/2. And then you can similarly check that this would be, so this would be 5/2. You can check that this would be 5/4. Okay. F of 1 is going to be 5 times 32. Okay, and let's see if we can do arithmetic in our head. That will be, I believe, 160, I think. And f of negative 1, this is going to be 5 times 32 to the negative 1, which is just 5 times 1 over 32, or just 5 over 32. Alright, sorry I didn't leave ourselves enough space here, but hopefully you can get this. So go ahead, do some examples in the homework, lots of practice, and we'll see you next time.